Hello and welcome to Mission AI's core Python programming course. We're now going to look at Module 5 today, and as part of Module 5, I'm going to cover Python functions, right? In the past, we've already covered all the basic data types, all the collections, and in Module 4, we looked at if-else statements as well as while and for loops, right? So now we're going to take this real-world programming a little further ahead and learn about one of the most powerful features in Python, which is functions, right? So I'll take you through the entire section, but let's start with a basic understanding of what is a function, right? Now, you remember while we were like right from the first module, I've been using the print function a lot, right? So print is a built-in function, but it is still a function. So you've been using functions already, right? And what does the function do? Like it performs a task for you, right? And you don't care what's written inside the function. You only care that you can call the function, you know what argument to give to it, and you know what output it gives you, right? So that's exactly the use of functions, right? So there's, I would look at it as two types. One is built-in functions, which Python has already defined for you, and the second one is user-defined functions, right? So in this tutorial, we're going to look at user-defined functions. Now, a function is basically it's a block of code that achieves a certain task, right? And this block of code is nothing but like related statements and operations. So whenever we solve any business problem or any technology problem, one thing that happens is, we constantly like there are certain functions that or certain operations that need to be done repeatedly, right? And rather than writing the entire code for that operation each time, what we can instead do is define a function that executes that particular set of steps, right? Set of statements. And then we just need to invoke the function every time that operation has to be executed. So rather than like keeping on writing the entire code each time, you just write the code once inside a function and then you just call the function as many times as you want. So there are also things you can do to make the function more dynamic, right? Like for example, you can supply different kinds of inputs to it, and on that basis it would produce different kinds of outputs. All that is possible, right? Now the whole point here is to make your code more modular, more understandable, and more reusable, right? You've heard of modularity and all these things, and that's basically like Python functions are one of the primary ways to achieve that, right? So you have a function with a very descriptive name, and that tells you what the function basically does. You have a description within the function that also tells you like what are the inputs it takes, what are the outputs it produces, and so on, right? And all the end user needs to do is call that function with this information that you provided. So some examples of tasks that we can accomplish using functions are like, for example, calculating the factorial of a number, right? It's the same set of steps each time. It's just that the number could change. So you would define a function where you take the number whose factorial you want to calculate as an argument, right? As an input. And then it'll just perform the same set of steps and give you this custom output in this case. Or for example, if you want to create a new user in the database, or you want to pull stock market data every hour, or you want to like print out the contents of a text file, right? Like in all these cases, the input might change, but the set of steps you're taking are the same every single time. So let's get into actually writing Python functions, right? So first I'm going to tell you about the structure of a function. So the first thing you're going to see is the def keyword, right? And that basically means define. So def followed by function name, right? And this is like I would always suggest give a nice descriptive function name, because typically you're going to be working in teams. There's very few cases you're writing code just for yourself. Typically it's going to be in a company and you're all working together to achieve some objective. So like follow certain conventions that the company has, and also like make sure the name is descriptive. So followed by, you say def function name. Next to that, you open and close brackets, right? And within those brackets, you provide all the inputs that you want to give the function, right? So like for example, in the case of a print statement, we're giving a string to the print statement, and the print function will then output that string uh, to the screen, right? So there is a clear input, which is this thing that we're passing, this object that we're passing to the print function. Like that single object, we also saw in the print statement, you could have a comma separated like sequence of values and it'll print them all one by one with a separator between them. So you've seen like how print can take one argument. You can see you've seen print take zero arguments also. It'll just print a new line character, and it can take like multiple arguments which are comma separated. So just like that, any function can be designed to take any number of input values, right? So you have a def function name, and then in brackets you specify all the input values, that is the arguments. And then just like you saw in if else, just like you saw in for and while loops, you have this colon right at the end, right? So this colon indicates to Python that my function definition is now starting, right? So everything beyond this belongs to my function and will be indented by one tab. So if the function is at the same level as all the other code in the main program, then the function's code would be indented by one tab, right? So I've already told you Python uses indentation to figure out what code belongs where, right? So like the code in an if block is indented by one tab from the if block. And the moment we go back to the original indentation, Python knows that that particular code block has ended. Okay. So now in this code block, the first thing you'll see here is the doc string. Now I've already told you the way for you to initialize multi-line string is using these triple quotes, right? Now your doc string is nothing but one or more sentences telling the user some helpful information about what exactly the function is trying to achieve, what are the inputs that it takes, and what are the outputs that it produces. So that description would come here, okay? Followed by that, you write the code to achieve your task, right? Like you can have 1, 10, 100, 200, whatever, any number of lines of code. And at the end of that code block, you might or might not want to return some value. Okay. So like for example, if I'm calculating the factorial of a number, there's two ways I can provide like value at the end of that function, right? One is I print it out from within the function, in which case I then don't need to return anything. In the second case, I return that value back to where the function was called from. Now I told you there's two things, like two steps with regard to a function, right? One is you define the function, and second is you call or invoke that function wherever you need, right? So wherever the function is called from, the value is returned back to that place. Now, for example, here I have a function, and in this function, the last statement is a return, right? And return followed by the output value. So what return does is it tells Python that the function has generated some output and I want you to return this output back to where the function was called from, right? Now, this is the part in the main program where our function is called, right? Now, if I were to think about just the function, remember it's very important to remember in Python, everything is an object. So naturally, even a function is an object, right? So if I refer to just the function name, I'm talking about the function object. If I put the function name followed by brackets, it means I'm invoking the function. Okay, so just remember the difference between these two things and it'll play an important role further in this tutorial. So if I just mention the function name without brackets, it means I'm referring to the function object, right? The object that contains the function definition. If I follow this function name with open and close brackets with all these arguments in between, then it means I'm invoking the function. So here you can see there is a function name followed by brackets, right? Which means this is actually invoking or calling the function. So when I call this function, the control passes from the main program into this function, right? All these arguments get passed, this processing happens, and then the return value is passed back to this area, right? And so this thing gets replaced by the return value and that gets assigned to variable with name var. So what you're saying is in effect, you're assigning the return value of this function to this variable, right? That's what I'm doing here. And you also need to remember that if I'm doing this at this point, if I'm performing this operation of calling the function at this point in the main program, then I need to make sure that the program knows what this function is, which basically means that the function has to be defined above this line of code, right? Naturally. So if I put this line of code right on top, then at that point, the Python interpreter hasn't yet encountered a function called function name. So it'll throw an error saying, I don't know what object you're referring to. So you have to define the function first and then use it in the program. So just a few things to remember here. The def keyword is used to define a function, right? As we saw over here. The rules for naming a function are the same as the rules for naming a variable, right? And we had seen this in module 2, that basically it has to be alphanumeric or and containing the letter underscore, the character underscore. So these are the only characters allowed, right? It cannot start with a number, and it is case sensitive. So make sure that you use the same case throughout, right? Now the input arguments are specified in brackets after the function name. Like for example, if we want to find factorial of 5, we say factorial in brackets 5, right? 5 is the input to the function. Now remember to specify the colon after this first line. You need a colon at the end, right? Everything that follows is indented by one tab or four spaces. So Python understands that that is what your function code is. After that, this docstring is really important to tell the end user what your function does, right? Now, if you remember in the last, at the end of module 3, we saw the help and the dir functions, right? The directory function basically lists out the entire set of attributes and methods for an object. And the help function gives you detailed documentation on a particular method, right? Now, if I say help of function name in this case, this docstring is what it will show me. This entire description that I've put inside this docstring is what will get displayed if I say help of function name, right? Which is basically this. Now, this return keyword, right, is optional. If your function just does some processing, like for example, insert uh, insert a user into the database, right? Now, you could return a value true if the insert statement was successful and a value false if it was unsuccessful. But at the same time, you could also just say, I'm not going to return anything, right? Because I'm just doing a database operation and the user doesn't need a return value. So this return statement is optional. But if you are doing some processing that has to be that results in a value that then has to be returned back to where the function was called from, then you use the return statement followed by the output value. And the function has to be called in the exact same format that it is defined, right? Like the function name has to match, the arguments have to match. So that's the basic structure of a function, right? So now let's actually write your first function. And remember, like you have to adopt like just logical approach into every bit of code that you write. So if I were to think about what are the like what are the things I need to remember when I'm writing functions, the first thing is understand the objective, right? Like what are you trying to achieve? Next thing is describe the inputs. The next thing is describe the outputs. And then finally describe how the inputs will get transformed into the outputs, right? So you're basically covering all aspects of this. So let's look at an example now. Now we are defining a welcome function to print a welcome message to the user, right? So if I'm printing a welcome message to the user, it's just a print statement. I'm not returning anything per se. And it does take one input, right? It takes the user's username as an input. So for example, I'll say def, right, which is the define keyword for function. Welcome, which is the name of the function. Now open and close brackets telling the function that these are the arguments received by the function. and there's only one argument called username, and this is the name of the variable, right? So whatever I pass to this function gets stored in this variable called username, and then I can use that variable inside the code block of the function. So for example, I'll say print hello and welcome, and whatever username is, I'm converting it into a string value just to make sure Python doesn't throw an error. Okay, so this is the function definition, but it doesn't mean that if I just run this much, that something will get executed, right? So for me to actually invoke the function, like over here, the first thing I'll do is I'll take some user input, right? Saying, please enter your name. And finally, I'll invoke this function. In this case, I'm not returning a return value, right? So I don't need to assign that to a variable. Just remember, in cases where there is no return value, Python by default returns none. Okay, so I don't need to assign that to any variable. I can just call the function directly as is, and in this case it will be welcome of this variable, right? This object, which was what I used to store the string from the user. So I stored that string and then I passed it as an input into the welcome function. And just because I called welcome by supplying the open and close brackets, the function has been invoked. And the moment Python encounters this line of code, it takes this input and dumps it here into the username variable, right? And then it executes the code block in the function. So it prints out this message, and that's what the user sees on screen. So let me just copy this and run it over here to show you. So in these first couple of lines, the welcome function is created, right? And it is an object inside the Python runtime. Now what happens is we create a new variable taking some input from the user, and we pass that to the welcome function while calling it. So let me run this. You can see that it says please enter your name. I'll just say Vikram, and it prints out this message, hello and welcome Vikram, which is what we wanted here, right? So basically the function has been called and it has done its processing and printed out the output. Let's look at another example, right? We have a square function to get the square of a number. Now, typically, what does a function like this require, right? It requires the number whose square you want, and it also returns a value which is the square of that number, right? So it has one input and one return value. Like in this case, I say def square, and it takes one input, which I'm going to call as input num, right? And then what I'm going to say is I'm creating a new variable called num squared, which is equal to input num to the power of 2. And remember, this is the exponent or to the power of operator, which we covered under arithmetic operators. So I have this variable that contains input num square, and I'm now going to return this variable, which is our output variable, back to where the function was called. Now, at this point, I have only defined the function. I have not yet called it. But back in the main function, which is basically at the same level of indentation as def, right? This continues being the main program. So print the square of 5 is, and then I invoke the function here, right? I call square, which is the function name, and I pass 5 as the value to the input num variable. And this returns a integer, right? Which is this number squared. And we know that if I concatenate a string with an int, it throws an error. So I pass that output to the string constructor, and then I concatenate it with this message, right? So let's run this code and see what we get. I'll just run it, and we get the square of 5 is 25, which is exactly what we hope to get, right? Now, this is an additional step, right? Like I'm saying num squared equal to input num power 2, return num squared. Another thing I could have done was just return this directly throughout the first line and just say return input num square. right? And I should get the exact same output. And that's exactly what I get. So we've seen how to define a function that either takes an input or doesn't, and it does some processing and either prints out the output value or returns the output value to where the function was called. Okay, so now let's do some exercises to kind of cement this basic understanding of functions. Now, write a function that returns the number of entries in a dictionary. Call the function with this dictionary as input and print the output. So the function, it takes a dictionary in and returns the number of entries in the dictionary, right? So there is one input value, which is a dictionary object, and there's one output value, which is the number of entries in that dictionary object. So I'm going to say def num entries, right? So this tells you that the function, what it does is basically count the number of entries. So num entries, and I'm going to say D is the dictionary, right? That's the input. So the variable in which that input is stored is called D. Now the colon to indicate that I'm now starting the code block as part of the function. So I want to count the number of entries. So I told you for any collection in Python, and a dictionary is a collection, the way I count the number of entries or number of items in that dictionary is I say len of D, len of collection, right? So I can just return len of, or in the first case, let me just create a variable, right? So entries equal to len of D, which is length of this dictionary object, which I've passed to the function. Then I'll say return entries, right? So I have defined the function. Now I need to call it from the main program. So I'll say D equal to this dictionary, right? And we can see that this dictionary has three entries, which are three countries as the keys and their population in billion as the value. Now it wants me to print the output. So let me just, for convenience sake, store the output as a variable, right? I'll say entries, or I'll just say num equal to num underscore entries, which is the function name. Now I'm going to open and close brackets because I'm actually invoking the function. And in this case, I'm passing an input, which is D. That is this dictionary that I defined over here. And finally, I'm going to print out num, right? So let me run it now using Control Enter. And I get 3, which is exactly what I was hoping for. That's the number of entries in this dictionary. So remember, in a dictionary, the number of entries is basically the number of key value pairs, right? And there are 3 key value pairs over here. Now, as I told you in the previous case, what I could have done to let me just show you a few ways in which I can write more concise Python code, right? So I would have just thrown out this entries part, just taken this len part, and I would have returned that directly, right? And so I have a dictionary with called D that I've stored in this variable, and I'm just returning the len of D, right? I don't need to do anything beyond that. So this is a way to make function code a little more like concise. And in this case, I've defined a new variable for the input. I've defined a new variable for the output, and then I've printed that output variable. What I can do instead of this is remove that D and just directly paste this dictionary object while calling the function. So I'll say num equal to num entries, and this dictionary object is getting passed directly, right? So if I run this now, I get the same output. Now another thing I can do is, why simply get the output into a variable and then print that variable, right? There might be cases where you need that variable, but not, this is not one of those cases. So I'll just say I'll delete this variable and I'll just print out this entire thing as is, right? So I've shortened the definition of my function, and I've shortened the statement that basically invokes the function and prints out its value. So remember, like, you're calling a function that's returning a value, and you're wrapping that value in the print statement here. So if I run it, I get 3, which is the exact answer. So you can see that this code is much more concise than the previous code. But for example, if the value of that dictionary changes each time, then you need to make sure you pass it as a variable and not as just this object. Moving on to the second example now. Write a function that takes an integer input from the user, right? So basically there's one input, prints hello world as many times as specified by the input. So for example, it asks the user for the input, and if I say 5, right, then it'll print hello world 5 times. And we have to achieve this using a for loop. So we've seen for loops in the previous module. So if you don't remember it, you can check up that module. If not, we can just go ahead right now. So I'll say I'm defining a function called echo underscore 5. So what I'm doing is I'm taking an integer input from the user and I'm echoing hello world that many times, right? So I'll say echo underscore n, not echo 5, sorry. So echo underscore n, and I'm just taking num, right, as the input. And what am I doing? I'm printing hello world as many times as specified by the user input. So I'm going to print hello world. And you remember, like I showed you that this multiplication operator does a job of repeating a string n times, right? So I can say hello world into, I don't know why I keep writing 5. It's hello world into num, right? And I'm just going to print out this message that many times. That's it. That's what my function does. Uh, Let me run it first, and then in the next case, I'll show you how to do it using a for loop, right? Now I'm going to invoke this function, and since the function does not return any value, I don't need to store the output from the function in any variable. I can just call the function directly. So I can say echo underscore n. How many times do I want it repeated? Let me just say 5 for now, since I've kept saying 5 all this while. And that's it. So it says hello world 5 times, right? Now, if I wanted these to be separated by a new line, then I would just add this new line special sequence in the message and I would run it, right? So then I get hello world in this particular way. Similarly, if I want it repeated only 3 times and not 5, I can run it with the argument 3, and now hello world gets repeated 3 times. Because what I'm saying is hello world into num, right? Now let me make sure that I show you how to achieve this using a for loop as well. So I'll remove the multiplication operator there, right? I'll say for I in range num, right? If you remember in the previous module, I had shown you how to execute a for loop a specific number of times, right? And we had done that using the range built-in function. So range of m to n will give us all the integers starting with m and ending with n minus 1. Now, if you don't specify m, which is the first argument, then it'll assume that's 0, right? So when I say range of num, like for example, if num is 5, I'm just saying give me integers from 0 to num minus 1, that is 0, 1, 2, 3, 4. And so all I'm doing is I'm running this loop n number of times, right? Where n is like specified by the user or specified by whatever I call in my code. And I've done one more level of indentation to indicate that this code is in the for loop and that for loop is in the function definition. So you can see that at each level, I go down one level of indentation. So for this function, I do one level of indent. And then because this print is within the for loop, I do one more level of indent, right? So now let me call it and I get the same output. If I call it 5 times, then it prints it out 5 times, right? If I call it 10 times, it prints it out 10 times. So that's how this function works. I'm using a for loop, and however many times we have specified that this hello world needs to get printed, it'll print it in this for loop. Moving on to the third exercise now. Write a function that returns the sum of all the elements in a list of numbers. So I've spoken to you about the list collection slash data type, right? And you have these elements at different positions. Now I want to get the sum of all the elements. So how would I cycle through this, right? What I would do is I'd probably go through each element in the list and add it to a variable called sum, and then return that sum back to where the function was called from. So there is one input here, which is a list of numbers. Now, it doesn't need to be of a specific length. It can be any list containing numbers, right? And the output is a single value that gives us the sum of all the elements in that list. So I'll say def list underscore sum, right? By seeing list underscore sum, the user automatically knows, or whoever's like using your code, or even you, for example, if you're revisiting this code after 6 months, you'll know that list sum will give you sum of elements of the list, right? And I say I have LST as my input, right? Which is a variable that holds that list object. And then the colon. So what am I going to do? I'm going to say for. So in the previous case over here, we saw how to execute a for loop n number of times using range. In this case, I'm going to use the for loop to just iterate over a collection. So all I need to do is for item in LST, right? So that's the for loop. And I just need to do one thing before that, say sum of items equal to 0. So I'm starting with this number of 0, and then I'm going to progressively add each element to that sum, right? And also remember that because it's inside the for loop, I'm going one further level of indentation inside. So for item in list, sum of items plus equal to this element here, which is item, right? So for each item in the list, I'm adding that item to the sum of items. And then finally, at the same level of indent of the code block of the function, I'll say return sum of items. And if you remember, this plus equal to is the same thing as saying sum of items equal to sum of items plus item. This is just a more like precise way of writing it, right? So now this function does what we want it to do. It takes a list as an input and returns the sum of items of that list as the output. Now I have to call this function, right? So let me copy this input list. I'm going to say print list underscore sum, which is my function name, and I'm going to call it with an input, which is this list, right? And this list gets stored in this LST variable, and that LST variable is then processed inside the function to return the sum of items, right? And the sum of items gets embedded here where the function is called, and it gets printed to the output. So if I think about it right now, 125 plus 250, 375 plus 375, 750. So 1400 should be the output, right? And that's what we get over here, 1400. So I have used a for loop to loop over each item in the list and to add it to the sum. And then I finally return that sum back to where the function was called from. Now write a function that takes a list of numbers and a boolean as inputs. So in this case, there are two inputs, right? One of them is the list of numbers. The other one is the boolean. Now, if the boolean is true, return the sum of all even numbers in the list. Else return the sum of all odd numbers in the list. And remember, I'm not talking about all odd positions. I'm talking about all odd numbers. So what I will do is I obviously have to have a for loop to iterate through all the items in the list, right? If I wanted to add up all the odd positions and even positions, then I would have gone by index. But I want the actual contents of that item. So in this case, I will just iterate over the each individual item in the list. So we're going to define this function and we're going to give it a meaningful name like even, odd, sum, right? And we've already spoken about it taking two inputs. One is a list, which I'll store in the variable lst, and the second one is a boolean, which I'll store in the variable b, right? So if b is true, we want the sum of all even numbers. If b is false, we want the sum of all odd numbers in the list. So let me start defining the code in my function now. So I'm going to iterate over all the items, right? And I could take two approaches here. The first one is uh, I I just like segregate all the items into even and odd. So I have a sum of even items, sum of odd items. And if B is true, I return the sum of even items. If B is false, I return the sum of odd items, right? So that's one way of doing it. The other way of doing it is I go through each item in the list. If B is true and the item is even, I add it to the total. And if B is false, then I check if the item is odd and then I add it to the sum, right? So let's go one by one. So in the first case, I'll just create two variables, right? One is even sum equal to 0, and I'll say odd sum equal to 0. And then I'll just go for each item in the list, right? If item mod 2 equal to 0, that is, I'm checking if the item is even. So it's modulo operator, that is the remainder will be 0. Then I'll say even sum plus equal to item. That is, I'm adding item to even sum, right? And if the item is not even, I'll add it to odd sum, right? So I'm creating this even sum and odd sum, and I'm just like conveniently segregating items as either even or odd, and I'm adding it to those specific variables, right? To hold those even and odd numbers. Now at the end of it, I'll say if B is true, right? So basically if B is one way of writing it, equal to true is the other way of writing it. But I'll just use if B, then return even underscore sum, else return odd underscore sum, right? So I've defined my function now, and it basically calculates a sum of even items and a sum of odd items. And if the boolean is true, I return the sum of even items, else I return the sum of odd items. Now let me call it, right? Let me call this function with the same input from the previous exercise. Let me call even, odd, sum. That's the function name, right? It's this. And I'm going to call it with two inputs, one of which is a list, and the other one is a boolean indicating whether I want even numbers or odd numbers. Now in the first case, I'll say even numbers. You can see in this list there are only two even numbers and two odd numbers. So the sum of the even numbers is 900, and that's the output I should get, right? And that's exactly what I get here. Now, if I wanted the sum of the odd numbers, I would just pass false over here, and then it would return odd sum from here, right? And that would be in this case 500, and we get exactly 500. Now, if I'll show you, this is dynamic, right? I could have added another thing here and another item here, and it'll give me like the values at that point in time. Like if the sum of odd items is now 1275 and the sum of even items is now 1800, right? So this is one approach of doing this. So I'll keep this statement as the same, but what I'm going to do now is I'm going to change how I define this function, right? So I told you the first option is you have an even sum and an odd sum and return depending on what the value of b is. In the second case, I will have only one sum variable and I'll add to it or not depending on whether the item is even or odd. So I'll remove this and I'll say sum items equal to 0, right? Now, if B is true, then I'm going to check if, sorry, the first thing I need to do is iterate over the list, right? For item in LST, right? And I'm going to indent these things. So for item in LST, if B is true and if this particular item mod 2 equal to 0, then I'll say sum of items should be incremented with the value of this item, right? So if this is true and this is false, then I don't really care about the item because that I'll take care about it. I'll take care of it in this particular case. So if B is not true, that is, if I want odd items and if item mod 2 not equal to 0, that is basically it equal to 1, it equals to 1, then I will say sum of items plus equal to item. So I'm basically saying I'm going through all the items in the list. If B is true and the item is divisible by 2, add it to the sum of items. Else, if B is false and the item is odd, add it to the sum of items, right? So now let me just say return sum of items. And I should get the same output as last time, right? Which is exactly 1800. And if I pass false, I'll get the sum of odd numbers, which is 1275. So you've seen two different ways of writing the same function, and you can see how the function call did not change. Like I did not change the code of the call, right? I only just changed what I had defined in the function. So you can see how there is a level of abstraction, right? Like the user doesn't care about what is inside the function. The user only cares about that interface, right? That is, I am telling them that this is the name of the function. These are the inputs you have to give. And if you give these type of inputs, these are going to be the outputs, right? That's all the user cares about. So when you write a lot of code, you need to understand that whatever's inside here is abstracted away from the user or like whoever else is going to be using your code. And you can write any kind of code as long as the function accepts this and returns the correct value of this. And you could see that even the function call does not change. So we've basically seen how to like use for loops within a function. We've seen how to like process different kinds of inputs. We've seen how to use nested if statements within a function. We've seen how to return values. We've also seen how to print values to output and so on, right? So that's like the basics of functions covered. Now we'll cover two very interesting things, which are what are the different ways of specifying inputs to the function, which are basically arguments, and the other thing is what are the different kinds of values that the functions can return, right? So let's look at arguments in this case. Now in the function above, right, like these are basically positional arguments, okay? So I am passing certain values here by position, and I'm in the function I'm interpreting them also according to their position, right? Like in my function definition, I'm expecting that the first thing will be a list and the second thing will be a boolean, right? So I can't reverse the order of those arguments and expect that the function will behave the same way. Like for example, if I change it here and I run this, you can see I get an error, right? That's because Python expected the first argument to be a list and the second argument be a boolean. So let me just move it back here. And now you can see that it runs fine. So you need to basically ensure that if you define a function this particular way, the arguments that are provided to the function are exactly as the function would expect. Now, if for example you wanted to give the user the option of like giving the list second and the boolean first, then within the function you would have done some processing, right? So you would have said something like if type of LST is list, right? And on that basis, you would have treated that argument like a list. Similarly, you would have checked if type is bool, then you would have taken that as the boolean input. So y- like you can't really strictly enforce positional arguments. What you can do in this case is you can do that processing within the function just to make the function idiot proof in a sense. So we've seen positional arguments, right? That is, the order in which they are supplied matters. There are some cases in which you don't expect the user to give all the inputs, right? Like some of the inputs might not be compulsory. In that case, there should be some default values to some of those inputs so that the function doesn't fail, right? So let's say I want to define a power function, right? Now, ideally, a power function takes two values. The first is the number that you want to find the power of, and the second one is the actual power or exponent, right? So what you would do is you do number one, power, number two, and return that value. But what if the user didn't specify the second argument? Let's just say they specified only the number whose power you want to find. Then is there a way you can make this function more user friendly? Like I would say there is, right? There is a way where you could say take the default value of the second argument as 2, so that if the user does not specify what power he wants, then you will return the number squared, right? So the default value of that second, the power number exponent is 2. What happens if you don't give that default value? Then if the user does not supply the value 2 or 3 or 4 or whatever he wants, then the function will throw an error, right? So let's look at this. We have a function that returns the first argument to the power of the second argument, where the second argument has a default value of 2, right? So I'm saying there are two inputs to the function. The first input like is positional, it's on the left side, and the second input is, I mean, it would be supplied on the right side. But if it were not supplied, then the default value of that input is 2. So you just say power equal to 2. So the way that works is Python says if power has been supplied by the user, then take the user's value. If it has not been supplied, take 2 as the value. And we return number with the exponent operator followed by power. So this is how you use arguments with default values, right? If you just think like the whole point of Mission AI is that we're going to teach you machine learning, right? And the core Python course is a way to get towards that. So if you think about all these machine learning functions out there, right? Like, or if you look at the scikit-learn library or even pandas, each function there has like tons of options, right? Like there are so many different options, it's impossible for a person to remember all. Now, there is no way you're going to remember the order in which to supply those things. Or there is also no way in which you can supply all those inputs each and every time, right? So there are some default values that are used, and those default values let the function run predictably. Like you say, these are the values I want to specify. For all other variables or inputs, use the default values. So I'll just run this code above and we'll like invoke this function. So I have this power function that takes number to the power of whatever the user provides. And if the user doesn't provide a value, then 2 is the default value. So I'll say print power of, let's say I want 9 to the power of 3, right? So I'll say 9 is what will go into the num variable and 3 is what will go into the power variable. So I'll just say enter and I get 729, which is 9 cube, right? But what happens if I just pass the number 9? Then I get 9 square, which is 81. Because now that there's no value supplied by the user for the power variable, it takes the default value of 2. Cool. So let's do an exercise to kind of cement our understanding of arguments with default values. So you define a function that returns the first argument to the power of the second argument, right? Where the second argument has a default value of 2. Call it with the values 8, 4, and 9 respectively. So what we're defining is very similar to this particular code, right? So I'm going to say define power, and I'm going to say uh, num, comma, uh, PWER, let's just say, okay? So I'm going to follow with a colon here, and in the function, I'm going to say return first argument, that is num, power, second argument, right? That's all I'm doing. I'm returning the first argument power second argument. But here, remember, I have to have a default value for the second argument, which is 2. So I say power equal to 2, and I return this value. And now when I call it, I'll say print power of, what do I need to supply? 8 and 4. So 8 to the power of 4. And I also want to get the value of power of 9 and see how the function behaves without the second argument to it. So in the first case, I get the correct value of 8 power 4. And in the second case, since I've provided only the number, then the default value of the power is 2 and I get 9 square. So we've seen how arguments with default values work, right? Now, in another case, I could say I need to consider whether there is a fixed number of arguments or are there a variable number of arguments. Now, in the previous case we saw there are two arguments, right? One of them is the number and the other one is its exponent. Now, in this case, let's say I want however many strings a user supplies to a function, I want to concatenate all those strings and return one string back to the user, right? So in this case, I don't know how many inputs the user is going to supply, right? Like some people might give 3, some people might give 5, and so on. And they should be able to give any number of inputs. And for that set of inputs, I'm going to concatenate them into one string and return the output. So I need to be able to handle a variable number of inputs. So what I do here in this case is I use an asterisk before this variable over here. I capture, I say I'm going to capture all the arguments in one variable, and the star indicates that it's basically a variable number of inputs and it's captured in the form of a list, right? So if I say I'm defining a function where I give a variable number of inputs, I'm going to, in this particular case, I'm adding the input items to a new list and returning it. So I'm creating this empty list over here. And for each item in args, so when I say star of args, it means that args is a list with a variable number of items. And when the user calls the function with any number of arguments, all those arguments are stored in a list form and accessible through the variable args. So I say for item in args, append this item to the list. And then at the end of this loop, return this list back to where the function was called. So if I say make list, and in this case, I say 1, 2, 3, 4, 5, 6, I've called it with 6 elements, right? And my final list should also have 6 elements. So let me run this code and show you. So if I run this now, I get a list with 6 items, which are all these comma separated items that I pass to the function. Now, if I add this, if I say 7, 8, 9, then the list will also contain 9 elements, which are the inputs that I provided. So however many arguments I provide to the function handles that many arguments because it basically accepts a variable number of inputs and stores them in a list form. So let's do an exercise to cement this, right? So we've seen already, I'm just going to keep reiterating this so that you remember. I have specified default arguments using the equal to operator, right? So I've said variable equal to 2 in the function definition. So that means the default value is 2. Remember, all the inputs which have default values have to be specified to the right, to the extreme right. Like you cannot have another positional argument this side. All of the positional arguments to the left and all of the arguments with default values to the right. Now, in the second case, I've specified a way of handling a variable number of arguments using the star args. So define a function that adds all the input items to a new list and returns it. So I'm going to call it with these input values. I'm going to append all those input items to a new list and return that new list, right? So I'm going to say def add to list, or actually let me call it make list, right? And we know that it just says all the input items, which means it could be any number of items. So I'm going to say star args, and args is just a convenient way to say it, right? Like it's like one of those industry standard kind of variable names. So everyone will understand what it means. So first I'm going to create the list variable, which is my output, right? So lst equal to this empty list. And then for each item in args, I'm going to append it to the end of this list. And finally, once the whole for loop runs, I'm going to return lst, right? And over here, I'm going to say print make list of these values. So I'm going to have 5 values here appended to the list, right? If I run it, whoops. Oh, sorry, I have to mention what I'm appending here. So lst.append item. So the list contains all these items that I've passed over here. Now, if I remove one of these items, then the list will contain only 4, right? And again, this is like I specifically said add it to a new list, right? But if I had not said that, what I could have directly done was just say return args, and the call works the exact same way, the function call. You can see that in this case, args is basically a tuple, right? So it's returned a tuple. Like I'll undo these changes, and I've created an empty list and appended it here. So it should now in this case return a list. Here we go. Cool. So we've seen how to work with a variable number of arguments. The next thing we look at is how to work with named or keyword arguments. So we've seen default values, we've seen variable number of arguments. Now in this case, we're going to use named or keyword arguments. I briefly touched upon this earlier, but what I'm saying is like in the case of like the scikit-learn library or pandas library, there's going to be so many different inputs you provide to a method or function. There's no way for you to remember all of those inputs, and there's no way for you to remember the order in which you supply those inputs, right? So instead of that, it's easier to remember inputs by name. Like, for example, if let's say I create this function here, right? Calculate is the name of the function, and it takes 4 values, right? Num1, num2, power 1 and power 2. Now, power 1 and power 2 have a default value of 2. And what it returns is num1 to the power of power 1 plus num2 to the power of power 2, right? So It might seem straightforward, but if I had 10 such functions, each of which did one small variation of the calculation, there is no way you'll remember what arguments go in what order, right? So if I run this, I say calculate, and instead of just passing 4 and 6, I say num1 equal to 4, num2 equal to 6. Now I've made it much easier for myself, right? Because I already know that power 1 and power 2 anyway have default values, and I'm specifying num1 and num2. Now, if I call the same function where I specify num2 first and then num1, it'll still give me the same output as the previous call, because the value of each of these inputs is still the same. The order of that does not matter, only the value matters. And now in the third case, I can say num2 equal to 4, num1 equal to 6, and power 1 equal to 3, right? I'm actually specifying power 1, but power 2 is still taking the default value of 2. So let me run these three function calls for this function above. So in the first case, what I should get is 4 square plus 6 square, right? In the second case, I'll get 6 square. No, I'll still get 4 square plus 6 square because num1 is 4 and power 1 is the default value 2. And finally, I'll get num1, which is 6 to the power of power 1, which is 3, plus num2, which is 4, to the default value of power 2, which is 2. So you can see that the output of this and the output of this is the exact same. Both give 52, that is 4 square plus 6 square. And in the third case, I can specify any values that I want. I just need to know that I can specify it in any order. I don't need to be forced to specify it in one particular order. So this way, like Python gives you a lot of flexibility to uh, to be efficient, right? Like you don't need to memorize everything. So now let's do an exercise to kind of cement our understanding of named or keyword arguments. So define a function that takes up to 4 inputs. The first two arguments are the base numbers, they are compulsory. The next two arguments are the exponents, right, which is the powers. Return the value of the first base number to the first exponent minus second base number to the second exponent. The exponents have default values of 3. Specify the input arguments by name. I'll say while calling this function. Cool. So let's define this function now. So what do I call it? I'll say calc, right? It's performing some calculation. So I'm going to say base 1, base 2. Then I'm going to say, because the first two arguments are the base numbers, right? Next two arguments are the exponents. I'm going to say expo 1, and it has a default value of 3 equal to 3, comma, expo 2 also has a default value of 3. So these are my inputs to the function called calc. Now I'm going to specify my colon. And what am I going to return? First base number to first exponent minus second base number to second exponent. So I'll say base 1 power expo 1 minus base 2 power expo 2. Right? This is my calculation. Now I want to specify the input arguments by name while calling this function. So I'm going to say print calc, and let me specify arguments by name. So now I can specify them in any order. Let me say I want the powers to be 4. So I'll say expo 1 equal to 4, expo 2 equal to 4. Now let's say I'm going to specify base 2 first, equal to, let's say 6, and base 1 equal to 7, right? So irrespective of the order in which I provide these arguments, the values will stay fixed. So I'm still going to get base 1, that is 7 power 4 minus 6 power 4, right? And I'll run the same calculation but specifying the arguments in a different form. This time I'll specify the base numbers first and then the exponents. If I run this, I get the same output in both cases, which is basically 7 to the power of 4 minus 6 to the power of 4. So I hope you understood that you can either perform like you can either perform calculations, you can either define function inputs using positional arguments or using named or keyword arguments. In this particular method, I showed you how to use named arguments. Now, if I wanted to use positional, the equivalent would be print calc of 7, 6, which is base 1 and base 2, 4, 4, which is expo 1 and expo 2. Right? If I run it, I get 1105. So if I had to perform positional arguments, I have to remember what comes in what order. But if I perform the calculation with named or keyword arguments, then I can specify them in any order. Now, moving on to like a variable number of keyword arguments. So in the previous thing, we just saw keyword arguments. Now we're going to a variable number of keyword arguments, right? So I've already spoken to you about variable number of positional arguments where we use the star of args, right, to access the values as a tuple or list. Now, if we have a variable number of keyword arguments, then we use double asterisks, right, like star star, and we then use the variable name kw args, which is basically saying keyword args. So if I specify the input this way, what I'm telling Python is the function called create customer takes a variable number of keyword arguments. So they're basically name value pairs. And what is the best way to store a name value pair? It's a dictionary, right? So in this case, we can access the names and values of these inputs using dictionary access. So you say for key comma value in either just kwargs or kwargs.items, you can print the key and value, right? Or in another case, what I would do is, like for example, let's take a real world example of this, right? So I would create a new customer in the database with the information that the customer has provided. Like some customers might keep their alternate mobile number field empty. Some other people might have address street 3, which is a field empty, right? So I'm just going to pass the fields that have values, and I will specify the name of the field and the value of the field, right? So I can say I can create a new customer with these keyword arguments, and then I can insert that customer object into the database. So this is how I would, in a real world scenario, I would use this keyword arguments, the variable number of keyword arguments, to perform some processing within the function. But in this case, all I'm doing is I'm accessing keyword arguments kwargs as a dictionary, and I'm printing out all the key value pairs from there, right? So let's say I run this particular thing here. So I'm calling this create customer function with all these different names of variables and values of these variables. I will access them as a dictionary within the function and print out the key value pairs in a for loop. And at the end, I'll also print out the entire dictionary accessible using kwargs variable. If I run this now, you can see that for each iteration of the loop, I have the name of the variable and the value of the variable. And there are 3 such lines, right? Name, age, and location. Now, at the end of it, I print out the dictionary, which contains each of these entries uh, with colon separating the key and value and comma separating each entry. So remember, star of args to handle variable number of positional arguments, and star star of kwargs to handle variable number of named or keyword arguments. Okay, so let's define a function to create a customer record, which is basically a dictionary, based on the information provided in the named arguments. Print out all the keys and values separately of this particular customer. right? So I'm going to say define a function. Say create cust record, right? And what I'm passing to it is a variable number of keyword arguments. So star star kw args, then colon, and I'm going to start the function definition. So I want to print out all the keys and values separately. Now I told you like how for a dictionary object, how do I access all the keys? I say dictionary dot keys, right? And separately I would say dictionary dot values. So I would say print kw args dot keys, and I'll just convert that to a list to make it easier. And in another line, I'll print a list of all the values. That's it. I don't return anything from the function. But now I'm going to call the function. And since there's no return value, I'll just call the function directly. I don't need to like capture it in a variable or put it in a print statement. So I'm going to say create cust record, and the customer's name is Vijay. So I'm going to say name, or in this case, like, yeah, first name equal to Vijay, right? Age equals 45. City equals Mumbai. Marital status equals married, right? So I'm just going to create this customer record and it'll print out all the keys and values separately. So you can see that I'm successfully managing to access all the keys here, which is the names of the variables, and the values are the actual values of that variable object. So just to reiterate, we've looked at inputs to the function, right? And these inputs, basically, you can specify arguments with default values, and you just use the equal to assignment operator. You can specify a variable number of positional arguments using star of args, and it treats this as a tuple or list, and then you can access that and loop through it for item and args. You can have named or keyword arguments so that there's no need to remember the order of the arguments, right? You can just supply them in any order as long as the name is right and the value corresponding to that name is what you intended. And you just say variable name, input name equal to value when you call the function like this. And finally, we saw how to specify a variable number of keyword arguments and like what kind of real world situation it might be used in, right? Like for example, creating a customer record. We saw that we could access using star star kw args. We can access the kw args object as a dictionary and loop through its key value pairs. So now we'll move. We've seen basics of functions. We've seen like very detailed look at all the inputs and all the ways in which we could supply inputs to functions. Now let's look at the ways in which we can specify the outputs of the functions, right? So I told you, like there are cases where the function just does some processing, like for example, inserting into a database or writing out some text to a file or just printing something to the screen, right? In these cases, there's no return value. So what happens in the function? I do the processing and that's it. I just continue writing my normal code in the main function after that. There's no return statement. So here I say define concat and I have star of args. So what that means is it takes a variable number of positional arguments and just concatenates all of them with a space in between, right? And then I'm calling this concat function with these different positional arguments, and all that happens is it gets printed to the screen. Like there's no return value, right? So I don't need to assign it to a variable or like enclose it within a print statement. So if I run this here, I get a sentence with a space between each of these strings. So let's do an example of this. Define a function that takes 3 string arguments and prints out the sum of their lengths. Call this function with these following inputs, right? So I'm going to define some lengths, and I'll say string some lengths. And what does it take? It takes 3 string arguments. I'm going to say v1, v2, v3, right? And all I'm doing is I'm finding the sum of their lengths and I'm calling it with a certain input. So I'll say sum lengths equal to 0. No, actually, I just need to say sum lengths equal to len of v1 plus len of v2 plus len of v3, right? And then we call this function with these inputs. So we say uh, string sum lengths of, I'm going to supply these 3 string arguments here. And it should, sorry, I should print out this value within the function. So print sum of lengths. So if I run this now, I get the value 19, which is basically 6 plus 9 plus 4, right? So the sum of the lengths of each of these strings. And now if I want to make it a little more, how do I make this function more dynamic, right? Instead of taking just 3 string arguments, how can I take any number of string arguments? So what I'll do here is I'll say star of args, and then I'll iterate through those args. For item in args, I will first I'll create this sum of lengths variable and assign it the value 0. And then for each item, I will increment the sum of lengths by the length of that item. Right? So I'll say sum of lengths plus equal to len of item. And then finally, I'll print sum of lengths. Now in this case, I should still get the same output for this. But what I can also do is then don't they, right? Now if I run it, it'll be 27. So I'm supplying a variable number of positional arguments, and the function is calculating the lengths of each of these arguments. So we basically seen what happens when the function does some processing and prints some value, but does not return anything to where the function is called from. So there's no return value. Now in the next case, let's say there's one return value, right? And we've seen multiple examples of this, like for example, calculating factorial or returning the square or square root of a number, right? So here I'm finding the square root. And so all I need to do is supply one input to the function, which is the number whose square root I want to find. And I'm returning number to the power of -5, which is half, right? That gives me the square root. And then I'm calling the function here inside this print statement, where I'm saying square root of 196, which is 14, into 10. So it should give me the answer 140 if I run it. Let's run it. And we get 140, right? So let's do an exercise to kind of cement how we work with one return value. So define a function that iterates through the string values of a dictionary and returns the length of the longest string, right? So in the first case, let's just assume that all the values of a dictionary are going to be strings. And in the second case, let's say we could supply any kind of value and it will only go through the string values and find the length of the longest string. So I'll say define function len longest string, right? And what am I passing to it? I'm passing a dictionary. So I'll just call it D, right? And so I'm going to say for each value in D dot values, right? And first I'm going to say I need to find max len, right? And I'm going to say max len equal to 0. So if len of this particular value, that is v, is greater than max len, I'm going to change the value of max len to reflect this new value, right? So for each value inside the dictionary values, if the length of this value is greater than max len, then I'm setting a new value of max len. And at the end of this loop, I'm just return max underscore len. Now in this case, I'm assuming that all the values of the dictionary are strings, right? And my function behavior is on that basis. So now if I call it, so I'll say print len of longest string, and I'm going to pass an input to it, which is this dictionary, right? I'm going to copy that. I'm going to pass it over here, and that's the only input into this function. So if I print it out, it gives me the value 6. So you can see that in this case, where the key is 2 and the value is second, the length of the string is 6, while the length of the other two strings are 5. So it returns 6, which is the length of the longest string. And now if, let's say, the dictionary can have any kinds of values, but I want to only find the length of the longest string, right? So I would perform another check. That is, if type of v is string, then I'll do these other things. So if the type is string, then if the length of that string is greater than max len, then I will update the value of max len, right? So now if I add a fourth value to the dictionary, a fourth key, whose value is, let's say, 1, 2, 3, 4, and let's say a fifth key whose value is, let's say, a list, right? 1, 2, 3, 4, 5, right? I should still get the answer 6. And even if the length of the list is longer than the string, I should still get the answer 6. If I had not checked for it, then len of 1, 2, 3, 4 would have thrown an error, and len of this list would have been greater than len of this string. And so if there were only 4 items and this was the fourth item, it would have thrown an error. And if there were only 4 items and this was the fourth item, then it would have given the wrong answer because it would have given me the length of the list instead of the length of the longest string. So I've shown you 0 return values. I've shown you 1 return value, which is the length of the longest string. Now let me show you multiple return values, right? So if you think about it, Python already gives you the data structures for you to make this happen, right? Like instead of simply like finding some complex way to, make the return statement more complicated, all you need to do is pass a collection back, right? Like for example, if I want my function to give me 3 outputs, right? Then I just need to like put those 3 outputs in a list or a tuple or a set or a dictionary and pass them back to where it was called from. Like in this case, I want to define a function to return a tuple containing the lengths of a variable number of lists. Now I'm going to obviously take this argument as star args. I'm going to create a new list called lengths, which contains the length of each list inside these inputs, right? So the length of the first list is 2, length of the second list is 3, and then it's 6. So basically, I'm appending these values 2, 3, and 6 to this lengths list, and I'm returning a tuple of lengths. So I'll show you how this works. So I should get a tuple containing the values 2, 3, and 6. And that's exactly what I get, right? So in a sense, I'm returning multiple values using the return statement, and I'm just taking advantage of Python's collections to do this. So if you want me to explain this function, I'll just quickly do it. So I'm taking a variable number of arguments, each of which I'm considering to be a list. I'm defining a, a length list, right? And to this list, I'm going to append the values of each of these list lengths. So for each list in this variable number of lists that are provided, the length of that list should be appended to this output list that I've defined over here. And then finally, I return a tuple of this output list. Cool. So let's do an exercise to see how we can return multiple values from a function. Return the tuple containing the three highest numbers of a list in descending order, right? Think about it. Tuple. So I'll use a tuple constructor to convert some values, right? Now, what are those values that are getting converted? What is the input here? It's some numbers that are present in a list, right? So there is one input, and what is the output? The three highest numbers of that input list. So I want a tuple containing the three highest numbers as my output, right? So in a sense, I am returning a single object, which is a tuple, but that tuple actually contains multiple values. So in effect, I am returning like three values. So if you remember, we use the sorted function to sort a sequence in ascending order. We've also seen the reversed function. Both these are built-in functions. We saw the reversed function in module 2 to reverse whatever the input is that you give to it. Like it could be just the list in input order and it'll reverse that and give it to you. In our case, we'll use the sorted function first to sort it in ascending order. Then we pass it to the reversed function, which then sorts it in descending order. And then we take only a slice of the first three elements of that reversed sorted output, and we return that in the form of a tuple. Okay, so define top three, and I'm going to take a list as the input, right? The list could be in any order. So what I'm going to do is uh, I'll write it out in a set of statements, and then I'll start combining those statements together, right? So sorted list equal to sorted, right? Then I'm going to say reversed sorted list equal to reversed of sorted list. So what I created here, I'm using here and then reversing it, right? Now the next thing I want is sliced reversed sorted list equal to just the first three elements of this list, right? And I'm going to say slice, let's say 0 to 3, right? So it gives me positions 0, 1, and 2. 0 would be the highest element, 1 would be the second highest, and 2 would be the third highest. So that gives me the three highest numbers. And then finally return this variable name. Right? So now if I call the function top 3 inside this print statement, and oh sorry, and I don't just return this thing, I return a tuple of this as the output, right? So let me pass this list as the input, and you can see that there are items in jumbled order. So I want the top 3 items. Now, which are the top 3 items? There's 800, there's 500, and there's 440. So let's see if that's what I get in that order. Made a mistake. Let me convert this to a list and then slice it. And this is exactly what I get, right? I have uh, 800, 500, and 440, which is the top 3 elements of this list in descending order. Now, if I want to do this in a slightly more like efficient way, I would say return reversed of sorted, right? And then I would convert that to a list so that I can slice it and then take the first three elements of that list and then convert the final thing to a tuple. So I can just throw out all this and return just in one line, I can return the output, right? And this is what I get. So I sorted the list, then I reversed it so I can get it in descending order. Then I converted that to a list so that I can slice it. And then I converted that final three elements into a tuple. So there we go. We've seen how to return multiple values in a collection, right? And instead of a tuple, I could have also returned it in a list like this. And it would have printed this as a list, right? I could have also passed it as a set if I wanted, but here the order matters, so I won't use a set. Now moving on to a really, really important concept. Uh, we're getting to the end of part one of this module, right? Like I'm going to take a break after this, and in the next part we'll look at uh, variable scope, inner functions, nested functions, closures, and decorators. So I'm going to end this particular video with a talk on lambda functions, right? Now, a lambda function is nothing but an anonymous function, and in a sense, it's a way of really quickly writing Python functions. Like you can see in the previous case, we did define of this function, then we wrote some code within that function. Like it takes multiple lines, and it's a little irritating at times. If all I wanted to do was create, let's say, return the square of a number, return the cube of a number, there should be an easier way to do it. So all I need to do is say, to define a function, I'll say lambda. Instead of using the def keyword, I use the lambda keyword, space, then the inputs to the function, right? In this case, there is one input, and in this case, there are two inputs, and these are comma separated. Colon, to specify that the function code is now beginning, and the output expression, which in this case is x to the power of 3. So all I'm saying is this is a function, I say lambda, that takes one input, which is stored in variable x, and returning x cube, right? And I'm enclosing the whole thing in brackets and assigning that to a variable. So now I told you, right, functions are first class objects. They can be stored in variables, they can be passed to other functions, they can be returned from functions. So in this case, cube is the name of this lambda function that returns the cube of a number. So if I say cube of 6, it gives me 6 cube. And the equivalent would be define cube, which takes one argument, and then return that argument to the power of 3. So if I run both these things, they give me the exact same output. So let me just comment out, or actually print cube alt of 6. So both should give me 6 cube, right, which is 216. But you can see that this is a much, much cleaner way of writing the code. So where you can, you should use lambda functions, like where you just want to quickly write a function as part of the code rather than having like a separate big function. Now in the second case, I'm defining a lambda function that takes two inputs and it concatenates them with a space in between. So basically it's expecting string inputs. So I'm going to print out the return value from this function where the two inputs are hello and world, right? And the equivalent function here would be to define using the def keyword a concat function that takes two positional arguments and returns the same output expression. So if I copy this and I paste it here, I'm just going to run the same function call. cat alt in this case, they'll both print hello world with a space separator. That's what we get over here. And this is the same string you get over here. So you've seen how to basically create a lambda function, right? So within brackets, use the lambda keyword, use space, then inputs, comma separated, then a colon, and then the output expression, and then close brackets. Assign it to a variable, and then which is basically the function name, and then you're calling that function wherever you need to call it. So let's look at a couple of examples now. Define a lambda function to calculate the difference between the product of three numbers and their sum, right? And what is the output when we use these inputs? Also write an equivalent regular function to perform the same task. So I'm going to say difference of prod sum is the name of the variable that I'm storing this lambda function in. Lambda, it takes three inputs, right? X, Y, Z, and it returns the difference between the product of those three numbers and their sum. So X into Y into Z minus, in brackets, X plus Y plus Z, right? So X plus Y plus Z is their sum, and X into Y into Z is their product, and that's the output expression, right? And all I need to do now is print this difference of sum, product and sum, for these inputs. Open and close brackets to say that I'm calling the function with these inputs. I run it, and this is the number that I get, 930, right? Now I also have to create a regular function to perform the same task. So I'll say diff product sum underscore 2, right? I'm going to take the same inputs, X, Y, Z. I'm going to return the same output expression, which is X into Y into Z minus X plus Y plus Z. And then I'm going to call the new function with the same input, right? And that function's name is diff prod sum 2. So in this case, I also get the same output. But you can see that it's much easier to write a lambda function than it is to write a regular function. So where you can, like if there's like a single number getting processed or some basic operation, just create a lambda function. So I hope you understand the lambda function. We use the lambda keyword instead of def. We don't specify the arguments in brackets like we do with a normal function. We just separate them from the lambda keyword with a space, right? After the arguments, you specify the colon, and immediately after that, you specify the output expression. And the brackets are not necessary to enclose the function, but it's a best practice. So that brings us to the end of video 1 of module 5. In this video, let me just run through it. We've covered what a function is. We've covered the basic structure of a function, right? We spoke about def, the function name. We looked at like how to pass these arguments, comma separated, to a function, then the colon, and then the entire block of function code, right? The doc string is what you get when you pass like useful instructions or documentation about the function. So if the user types help of function name, this docstring is what will get displayed. Then you have your code block to achieve your task. And then finally, you may or may not have a return value, right? And this return value uh, could be either a single value or a Python collection that contains multiple values, right? We also saw these different ways of supplying arguments to a function, right? There was the normal positional arguments. Then there were default values for those positional arguments. Then there were variable number of arguments that we dealt with using star of args, and we treated that as a tuple slash list. Then we had named or keyword arguments, where when you call the function, you pass named arguments. That is, you pass the argument name as well as the value of the argument, and you can supply them in any order. After that, we looked at what happens if you have a variable number of named or keyword arguments, right? Like in the case of creating a new customer record or inserting that into the database. And the way you deal with that is using double asterisk followed by KW args, right? Which is basically keyword args. And you can treat that keyword args variable as a dictionary and you can access the key value pairs. Then we also saw how to return zero values, one value, or multiple values from a function, right? And finally, we saw lambda functions, which are basically anonymous, simple, easy to write functions that make your code much more like easy to read and much shorter. So the format is in brackets, you put lambda, then space, then comma separated inputs, then a colon, and then finally the output expression. So we wrote a whole bunch of lambda functions as well as their normal regular equivalents. See you in the next video where we cover nested or inner functions and closures as well as decorators.